Okay, so hello dears, good day again. So we are here again for another pre-recorded lecture in your bacteriology laboratory class. And for today's topic, we will talk about colonial morphology, colony characteristics and form. Now, this topic was supposed to be included sa inyong bacterial ID na topic last week, but then nakalimot ko ato na week na hala na pa ni, so ako na lang siyang gi-include karon together with the pure culture techniques. Well, in a way, ano naman po siya, same ra po siya o, you know, like flow. Kaya diba, after natong pure culture techniques, nag-culture ta, yes, na naitubo atong mga plates, woo, na mga kagaw, yes, party, pacture. Pero dili ta mo stop there, right? So after na itubo sa atong culture media plates, right? So na mga colonies, now we get to describe them, okay? And also, furthermore, in a way, would help us or would aid us in the identification of our organism. Okay, so again, this is colonial morphology. Again, from Sir Jemu. I don't have the PowerPoint na copy, so wala ko niya nahatagan. But na may PDF, so we'll use the PDF na lang. Okay, all right. So we'll start first with colonial morphology. Why is it important, or siyang is importance? Number one, again, it can give you a presumptive identification of the possible identity of your organism. But that does not mean that it can give you the definite, okay, identification. Please take note, don't be confused. I think Naini asked na ninyo na ako, I think usa ka section ako, previous mga August pa to, sir, ma-identify ba nato ang kagaw through colonies? Presumptive lang, okay? But it's not definite, okay? Because we need to still perform further biochemical testing and other tests to really speciate or definitely identify your organism. But your colonial morphology can help, okay, as a presumptive. It's not definite, but it can give you already clues or information as to what is the possible identity of your organism. Okay, so again, muna siya pasabot sa presumptive identification. Next, you have enhanced the quality of patient care through rapid reporting of results. Because tayo ubang bacteria, guys, na may mga characteristic colony appearance or colony morphology. And through that, usahay man good, depende sa lab pod, murag mo limit na sila or they would dito na lang kutob, dito na po sila taman, mo-report na sila sa identity of the organism. But again, generally, dapat yun ta guys, dili ta mo salig lang sa colonial morphology for identification. Okay, it's only just a presumptive, okay, means of identifying your organism. And last is, of course, you play a significant role in QC and other, especially in mga automated na systems. Because again, through colony morphology, example, you want to check the QC of McConkey, right? So dapat kung lactose fermenter siya, dapat unsay color siyang colonies, dapat pink, inana. So in a way, your colony morphology or colonial morphology will again prove that your certain reagents ba or culture media are working well. So muna siyang under siya sa QC. Okay, I do hope that's quite clear. Again, ako na yung emphasize, colonial morphology is not used, okay, or we cannot definitely identify. Like, dili ta maka-definite identification sa atong kagaw based lang sa colonial morphology. It can give you presumptive lang. It can give you already a glimpse or initial information as to what is the possible identity. But we don't stop there, okay? After colonial morphology and other tests like gram staining ba, katong bacterial ID na topic, we'll now proceed to biochemical testing. And furthermore, if your lab is really high-tech, mga molecular tests, which would really accurately identify na yun, the organism, okay? All right, but mostly in routine clinical labs sa mga hospitals, usually kutob na tag biochemical testing, okay? Or Vitec, which is a machine. All right, so inana na siya. Again, that's the importance of your colonial morphology. Now, we will have the different types of, or we will discuss the different colony characteristics. We'll start first with hemolysis. Size, no? What are the words to describe size? You have form, margin, elevation, density, color, pigmentation, consistency, and odor. All right, so these are the different mga characteristics sa colonies of your kagaw na pwede natong i-examine, pwede natong i-note. Again, that could again give you an initial identification, initial information as to what is the possible identity of your organism. But then again, emphasize, dili na ta kutob dire. Okay? Di ta parehas sa uban na mo give up or dayon. Charot! Okay, so move further pag after colonial morphology, usually mo proceed ta to biochemical testing or other tests to really identify na gyud the kagaw. All right? Okay, so we'll start first with the hemolysis. Of course, your hemolysis di ba na-mention na ni sa differential media, we observe hemolysis sa blood agar plate, yes naman. Di ba? We have complete hemolysis na clearing of colonies, no? Clearing of the media diay around the colonies. So you have beta or complete hemolysis. You have your alpha hemolysis, di ba? Alpha na greenish discoloration sa media. And no hemolysis is gamma hemolysis. Now, how do we interpret hemolysis? We use trans-illumination. So basically, your plate, di ba na naitubo, ito na siyang ibutang against a light source. Okay? And dito na ito makit-an ang iyahang hemolysis. That's what we call trans-illumination. So, naa sa likod sa blood agar plate ang light. Okay? So, basically, dili siya direct illumination. Muagi sa ang light sa imuhang agar plate, and then that's the light that now passes through to your eyes. Muna siya trans-illumination. Trans meaning niagi pa ang light into something before it reaches your eyes. Okay? So, that's how we evaluate hemolysis. Okay? Again, blood agar plate, nako, pag if question ako, unsa ka pag-evaluate on what culture medium do we observe hemolysis, and I mo answer og chocolate agar, ang bota lang yon, hagbong na ako diretso, charot na. Okay, alright. So that's for hemolysis. Next, we talk about size. It can be measured in mm or pwede pong estimate lang. Like, lantawon nimo siya based on your subjective lang, kung sa imong paglantaw niya. So, pinakagamay is pinpoint. Usually, pinpoint colonies, if I'm not mistaken, pinpoint S-pyo. Your colonies of S. pyogenes are pinpoint gray beta hemolytic colonies, I think, yeah. Small, medium, and large. Usually, for large colonies, usually mga gram-negative, bacilli, usually dagko na sila colonies. Alright? But generally, this is how we describe the colonies in terms of their size. Okay? So, it could be pinpoint, small, medium, large. Okay? Walang extra large. Dili niya siya sinina, guys. Okay? Alright? So, pinpoint, small, medium, and large. Alright? So, again, pwede siyang i-measure yun mo in millimeters, or pwede po siyang i-estimate rin mo. Or like, based on how you see, subjectively, the colonies. Okay? Alright. After size, we now go to form. Okay? So, overall shape of the colony, yung itsura. Is it like, punctiform, meaning pinpoint, mga S. pyogenes usually, or mga other gram-positive cocci in ana ilang colonies. Circular ba siya? Round, in ani. Filamentous, murag na siya mga buhok-buhok. Buhok-buhok. Or like na siya mga filaments outside of the kanang colonies mismo. You have irregular, dili siya complete. Rhizoid, murag roots, yeah, ang point na rhizoid, and curled in ani. So, depende na siya again on the kagaw or on the bacteria that grows. Alright, so filamentous, basically, you observe this type of colonies or rhizoid siguro in mga fungi, usually, or mga filamentous bacteria. Filamentous bacteria, example, si Actinomyces or Sinocardia. Okay? So mga filamentous, mga fungi-like bacteria. They're not fungi, but they're bacteria. Pero ilahang appearance, under gram staining or sa culture usahay, murag fungi. Munang they're called fungi-like bacteria. Okay. Alright. So yeah, in terms of form, so you describe it on siyang itsura. So circular colonies, punctiform colonies, inana. Okay. Rhizoid, inana. Okay. Alright. Next for margin, so the edge of the colony, the edge of glory, char. Okay. Wale mark. Okay, edge of the colony, you have entire, meaning medyo smooth ra siya, no? Undulate na ay murag mga protrusions. Filamentous again na ay murag mga mga fibers, or in a way murag siyang mga protrusions po na ginagmay. Curled is in ani, all right? And then lobate, murag siya fingers na itsura. Okay? Pero imo na siyang i-observe if kani ang colony. So, edge, kani mga sa edge, imo nang i-observe. Okay, muna point sa margin of the colonies. Okay? Alright. Next, you have elevation. So, basically, we look at if the plate, no, pwede nato siyang lantawon, i-tilt sa side, and then makita ng elevation sa colonies. Pwede siyang flat. Okay? Uy, marami ako mga friends na flat. Back-to-back concert. So, joke lang. Joke, I love my friends na mga flat. Okay. Alright, next you have raised, medyo elevated, gamay. Okay. Convex, yeah, mara siyag mountain, mara siyag hill. Okay. Yung pulvinate, medyo steep, mas raised siya compared to convex. Okay, as you can see, mara na siyag mountain na yun, no? Alright. And then, umbonate, mara siyag boobs, actually. Actually, that's how I remember. Umbonate, mara siyag umbonate na siya nipple, yes. Actually, Mura siyang boobs. Okay, sana all na boobs. Charot. Okay. Next we have umbilicate. Daghan siyang, mura siya bulubundukin. Yes. Elementary man ay nino, mga anyong lupa. Yes. Umbilicate. Mura siya different, na mga different elevations. Yes. And growth into the media meaning, ano na siya, ang culture, ang colony mismo kay ni grow na siya within the media. Usually, ma-observe niya siya sa mga fungi pa rin. Okay, because your fungi, man good, they have the vegetative hyphae, you have the aerial hyphae. Mycology? Yes. So you have the vegetative hyphae and the aerial hyphae. Okay? So basically, sa imong culture media, if imong colonies in ana, so nana siya yung mga inana ang fungi, and then napod diri. Okay, so let's say muna siya culture media. So your aerial hyphae, basically ginagamit na siya for reproduction, dira sila magpagawas og spores. Ang vegetative, by the name itself vegetative, sila ang mo supplement og nutrients. Okay? So sila nang mo kut-kut sa culture media. Okay? Alright, so mycology na ni. Okay na siya. Okay. Alright, so that's again for elevation. So side view imong lantawon. Again, depende na nimo on how to describe it. Okay? It be flat ba, raised, medyo elevated gamay, convex, gipa elevate pa jud more, and then ang pulvinate kay medyo increase na good ang colony. Ombonate again murag boobs. Umbilicate is murag siya bulubundukin, yes naman, Sierra Madre. Okay. And growth into media like ni seep na gyud siya or ni kutkot na gyud siya sa media. Okay? All right, so that's for elevation. Next for density, in terms of unsa kadaghan ang colonies, unsa ka bacteria nasa colonies. So naiuban na gamay ra kaayo sumunang transparent, so it allows most or all of the light to pass through. You have translucent, some light lang, and then you have opaque. Opaque niya siya guys ha. Medyo wala nakita. Opaque. Okay. Opaque meaning wala na dyan light na makita. Okay? Or wala na yung light na mo pass through sa colonies. Okay? So, how do we, usually I can't recall na among like sa lab yun mismo ginaano ang density, but in terms siguro of pagsiga nimo sa light, itry nimo pasiga ng light ng colonies, and then if napay light na murag mo reflect or mo pass through the colonies, then of course it's transparent. If some light lang, translucent, and if wala na gyud, then you have opaque. Okay? All right. For color again, usually if non-differential media nimo, example like dili like mga nutrient agar, mga katulad yung basic na mga media, non-differential. If na color na ma-produce, you can really say that it's the bacteria's pigments ang ga-produce, right? It's the presence of the pigments of the bacteria, meaning it's innate to the bacteria to really produce pigments or color, okay? But if na siya sa differential media, example, MAC, sa pa man ng mga differential media, you have XLD, mga inana. If na ay color sa colonies, it's because of their metabolic processes and also the presence of pH indicators. Okay, please take note. If na color in non-differential media, then you can say na it's really because of the bacteria's innate ability to produce pigments or to produce color. Okay, and if in differential media naman, example MAC, XLD, it's because of their differences in their ability to metabolize, example, a sugar, and because also of the presence of pH indicators. Okay, so muna siya difference lang if sa pigmentation, okay, or color. So again, there's a lot of colors, no? Pwedeng white, gray, buff, yellow. Usually, most of katong mga common na bacteria, usually mga white colonies na sila, or gray, na iba na buff. Yellow, very obvious. Sa BAP, you have creamy, yellow, butyrus, buttery looking. Diba? Press the buzzer, sino yan? It's Staphylococcus aureus. Muna siyang aureus, di ba? Aureus, because aureus means gold. Okay, di ba? Di ba? In Latin, di ba, your chemical symbol of gold is Au. Okay, di ba? And Au in Latin means aurum. O, di ba? So, muna siya aurum aureus, kaya it's gold yung color, di ba? Yellow, buttery looking, and okay, so that's for Staph aureus. Gold, aurum, Au, gold. Okay, all right. Okay, so here's an example of pigmentation. For pigmentation, again, it's the innate ability of the bacteria to produce pigments yun. So, mo produce yung pigments. Example, ana, you have very common yun, pinaka-common is Pseudomonas aeruginosa. Now, Pseudomonas aeruginosa is a well-known pigment producer. So, munang sa una manggod sa among lab or inyong lab supposed to be dapat karon, you will be given a known bacteria at the end of the semester. And then, imo na siyang identify. Okay? So, basically, if maka-receive kag nutrient agar, okay, nutrient agar yun, non-differential media na ni green ang medium, press the buzzer, muna ako nadawat, kabulon ako daan. Like, nakathink na ako na, this could be Pseudomonas. Okay? Because again, Pseudomonas aeruginosa is well known to produce pigments. And it's well known to produce a lot of pigments. Ang pinaka-common niya is the green one, and that is pyoverdine. Okay? Pyoverdine. Pwede po siyang produce blue, you have pyocyanine. Okay? Pwede po siyang red, pyorubin. And pwede po siyang brown, pyomelanin. So, depende siya sa color na iyahang gina-produce. Pero ang pinaka-common is pyoverdine, the color red one. So, depende po siya. Pyoverdine, green, pyocyanine is parang blue, pyorubin is red, and pyomelanin is parang brown. So, again, it will depend. Ang name sa pigment is dependent on the color na yung gina-produce. Okay? That's Pseudomonas aeruginosa. Another organism that's well known to produce a pigment is Serratia marcescens or Serratia. Serratia marcescens is a gram-neg bacilli. Okay? And it's an enterobacteriaceae, meaning na siya sa imong mga enterics. Okay? Serratia. And it produces a red. Kanino, nice kaya siya na pagka-red, you know, it's like really blood, no? So, red, the name of the pigment is prodigiocin. O, diba? Prodigiocin. Okay? I think under room temperature mo produce siya, ani. I'm not certain na. Nalimot ko. Pero ang name sa pigment is prodigiocin. That's color red. It gives the red color sa imuhang Serratia marcescens. Very characteristic Japon. Non-differential media, culture media like nutrient agar, na ay red discoloration sa media, then that could be Serratia marcescens. Very good. Very nice. Actually, your Serratia marcescens is known as your kanang huli bacteria, like kanang because you know there are instances daw if you're Catholics, diba, kanang pag-break daw sa bread during mass na yung red na mo appear, which is the blood of Christ daw. And then pag culture nila ato, ang ni-grow daw is Serratia marcescens, diba? So interesting. So it's Serratia marcescens daw. Muna ang Serratia marcescens is known as your, hindi mo ko sayang name, pero basta related to that, murag blood of Christ or holy or parang body of Christ bacteria, something. Sorry. Nalimot ko sa name. Pero yeah, because of its red pigment, pwede siya maalaan ko na blood. Okay. And last one is, of course, your Chromobacterium violaceum. By the name itself, violet. Diba? This is also your standard for quorum sensing. Na remember, quorum sensing. Sa intro to micro, diba? Quorum sensing. Okay. Chromobacterium violaceum. Basta gani, mo release og violet colored na pigment sa colonies, imo mga case study, violet colored colonies. Kanipod is ammonium cyanide odor, o diba? Ammonium cyanide odor, press the buzzer, Chromobacterium violaceum. Wag na maisip anong color ng colonies niya, it's violet, nasa ngalan na. Okay? Army ni siya, guys. Okay. Bakit violet ka, Chromobacterium? Army ka ba? Okay, joke lang. Alright, okay, so that's a different pigmentation. Just some of the examples of the bacteria that are well known to produce pigments. Napay mga uban, okay, but yeah, kanilang sa, okay? Alright. Next for consistency. Wow, sana all consistent. Charot. Consistency, okay. Yeah, determined by touching the colony with a sterile loop. It could be dry, yes, like me. Charot lang. Okay, it could be brittle or friable, like marupok. Ako na po. Wow, grabe. Patama. Ani na adlaw. Okay. Brittle or friable, marupok. Dali ra siya mo-disintegrate pag touch nimo. Moist. Oh, basa-basa. Sana all. Mucoid, medyo sticky. Viscid, creamy or butyrose. Mura siya buttery. Okay. Staph aureus. And waxy. Mura siya na-oil na pagka-texture. So, again, it depends on you on how to describe it. Okay, so, but you touch it with a loop and then imong ilang taon kung mucoid ba siya. Example of mucoid colonies diay, since na-mention ang mucoid. Mucoid, di ba? I mentioned, these are usually the colonies of mga encapsulated bacteria. Ayan. Because again, of their capsule, munang mucoid ilahang colonies. A very, very good example is Klebsiella. Grabe dyan ka, mucoid ilahang colonies, like as in it's so nice. Klebsiella, pneumoniae, or pneumoniae. Okay? Very mucoid, because again of capsule. So again, if mucoid ang colonies sa imuhang kagaw, then it could be na encapsulated siya. So, muna siya guys ang point sa Colonial Morphology on how it provides presumptive identification. So, kani pa lang daan, mucoid colonies, gani, makathink ka na mucoid colonies. Okay. So, akong organism pwedeng encapsulated. Okay, ayan. Not all naman, pero most of your encapsulated organisms, mucoid colonies. Yes naman, mucoid. Example, Klebsiella. Alright. Okay. And next, odor. So, abi niyo sa ihi ra na odor. Of course, naapod diri sa bacteria. Naayobang mga, again, kagaw na release ng odor, characteristic odor, because of mga different chemicals na lang gina-release during their growth in ana. And a very good example, and how do you evaluate odor? Pag open pa lang nimo sa plate, mas-smell nimo. Naayobang RMTs na akong na-experience sa hospital, na baton is ilang yung i-smell. Like, i-open ang plate na nilang i-smell, okay? Or naayobang na ilang i-ana ang plate para marag mo ang smell, or ang uban i-waft, like i-ana ba. Okay? But again, pag open pa lang na daanin mo sa plate na naka-smell na odor, very characteristic. So example, you have Staphylococcus aureus, old sock. Okay, wala akong kabalon sa smell sa old sock. I don't want to know pod, pero yeah, old sock daw yung odor. Next, for Pseudomonas na pod. Si Pseudomonas, guys, no, dagan kayo siyang pabibo, like dagan kayo siyang mga odor ko, no. So Pseudomonas aeruginosa is fruity or grape-like. Also, gina-describe siya as corn tortilla. Okay? Corn tortilla like odor. Basta ka ng fruity, grape, kana usually grape-like odor, corn tortilla-like odor. Yeah, press the buzzer. Wala na yun na. It could be Pseudomonas aeruginosa. And this odor is caused by the chemical na iyang gina-release named 2-amino acetophenone. Ayan, di ba? Okay. 2-amino acetophenone. If I'm not mistaken, this is an ester. Okay? If wala ko na sa'yo pa, may ganda akong org chem. And esters usually are very, nasalay smell, di ba? Alright. So again, your Pseudomonas aeruginosa, mo-release siya og odor na fruity or grape-like. Or again, corn tortilla-like. So pwedeng fruity / grape-like / corn tortilla-like odor. And what is the chemical that is responsible for that? 2-amino acetophenone. Okay, that's the odor. That's the chemical that causes the odor of Pseudomonas. All right, and Haemophilus, you have mousy or musty. So marag nima ko siyang daga. Okay, unsa tong yes, press the buzzer. Yes, makagamit ko anig CM. Kinsa tong ihi or unsa tong disease daw na naay mousy odor? Nako, sinasabi ko sa inyo, same ra batag handout sa CM. I think sa lab. Mousy musty, that's your PKU. Phenylketonuria. Ayan. So, dili ra pod sa ihi na mga odor na pod diri sa atong mga kagaw. So, for ihi, PKU, phenylketonuria. Mousy urine. Mousy odor of urine, PKU. Alright. Okay, but for kagaw, mousy or musty na odor, you have Haemophilus. Other organisms na wala dira, since di na ko ma-edit, kay PDF siya. Other odors, example, burnt gunpowder daw. Gunpowder or chocolate. Yes, lamia chocolate na smell. Or chocolate cake daw. Ano ni siya? Si Proteus. Okay? Please take note. Proteus. Burnt gunpowder, chocolate, or chocolate cake na odor. Kinsa to? Press the buzzer. Proteus. Another one is apple. Apple odor. Apple odor. This is alkaligenous. Okay? Alkaligenous. Another one, the odor of potatoes daw, guys. Potatoes, you have Serratia odorifera. O, diba? Nani sa mga Baileys usually. Alright, Serratia odorifera. Apple odor, kinsa tong apple odor? Alkaligenous. Kinsa tong potatoes, ang odor, you have Serratia odorifera. Alright, and last, dagan kay guys, sorry naman, dagan mga odors. Na may uban gud mo gawa sa boards. So you have also ammonium cyanide na mention ganina. You have Chromobacterium violaceum, di ba? Next, you have also smells like roses, di ba? By chain smokers. Psychrobacter. Okay? And last one is the smell of sauerkraut. So sauerkraut is like a dish in the Western or sa mga Swedish. This is Igna vigranum. Sorry kay guys, mga unknown na ni siyang bacteria, pero na siya sa Baileys, man good. So Igna vigranum ruofiae. Ruofiae. Okay? Alright, this is, I think, a coxsay man, guy. Yeah, Igna vigranum ruofiae. Sauerkraut odor. Alright. Okay, so, ayan. So, that's for odor. Pero again, ang pinaka-common kani sila. Okay, so please take note. Additional rin siya para pag abot sa review, medyo familiar na. Yes naman. Okay, alright. Ayan, okay. So, I think that's the end. Yeah, that's the end for colonial morphology. Again, ako rin emphasize your colonial morphology ng mga characteristics. Again, this will not replace the importance of kanang biochemical testing and further testing for the definite identification of your bacteria. These, again, are just presumptive. It gives you an initial identification or information as to what could be the possible identity of your bacteria is. And example, again, there are different types or certain types of bacteria na may mga specific colony characteristics. Example, diba, bullseye colonies on your CIN, sige nagbalik-balik, kinsa ni, Yersinia enterocolitica or Euromonas, pwede po. Fish eye colonies on EMB, kinsa ni itong fish eye colonies on EMB, you have Enterobacter. Okay, alright. So, now I'll let you see some pictures. Okay, since wala na ako siya na-incorporate dito, kaya di na ako ma-edit kay PDF. Sorry naman. So, I'll just let you see some pictures. Okay, so first one, this one, yes, di ba itong na-mention. Fish eye colonies, di kayo klaro. Pero siyang mga mata sa isda, okay? That's again Enterobacter. And for this one, again, green, metallic sheen on EMB, that's, wala nang iba, that is E. coli. Okay, alright. Next one. You have, not this. Sorry, mali. Okay. All right. This one, this is what we call molar tooth colonies. Meaning, mura siyag molar tooth, mura siyag tango. Okay? All right. So, molar tooth colonies, characteristic ni siya of actinomyces. Okay? Actinomyces. Okay? Same silang family sa nocardia. It's a fungi-like bacteria. Okay? So, meaning, dili dyan siya fungi, mura ra siyag fungi. Okay? Pero bacteria gid siya. Because under gram staining or under microscopy, marag na siya mga hyphae. Okay? Again, hyphae. Marag siya na yung mga hyphae, which is, makita na sa fungi. Okay? Marag siya na ay hyphae. Alright? Pero diligid siya tinood na fungi, bacteria, yapon siya. Fungi-like bacteria. Molar tooth colonies. Marag tango, actinomyces. Okay, next one, you have, yes, this one. This is the cover photo sa ako ang section D, di ba? Sa bacte, yes, mga section D dyan, mag-ingay. Okay, alright. So section D, this is what we describe as Medusa head, di ba? If you're familiar with your Greek mythology, Medusa head colonies, yes, mga ano dyan, mga demigods, Percy Jackson, hello, kaway-kaway, joke, okay, exciting. Okay, anyway, Medusa head colonies, this is characteristic of Bacillus anthracis. Okay, alright. Medusa head colonies on BAP, diay, on BAP. Okay? Alright. Bacillus anthracis. Okay, as you can see, di ba, magmuni siya ang head kuno ni Medusa and then muni mga snakes. Alright, di ba, Medusa, snakes iyahang hair. Okay, because gi-curse siya ni Athena. Kay gi-rape siya ni Poseidon sa temple ni Athena. Oh, that's another topic. Okay, anyway, I love it. I love Greek mythology. Anyway, again, Medusa head colonies, Bacillus anthracis. Okay? Again, cover photo sa section D. And ang cover photo na po sa section F, yan, characteristic. Oh, di ba? Very nice. It's so nice. Bloody red. Bloody red. I love it so much. Di ba? Next case of color good. This is, wala nang iba. Kaysa itong red colonies na to, we have Serratia marcescens. And unsa ganito na pigment ang nakakos yung pagka-red, prodigiusin. Alright. So, basically, those are just some examples of colonies. Again, I just like to highlight na po na colonial morphology or ilahang characteristic colony appearances do not replace other tests na atong gina-perform for their definite identification. As mentioned sa start palang daan, colonial morphology only serves as a presumptive identification tool, or it can also help, okay, to further solidify our assumption on what is the probable identity of the organism. Okay, so yeah, that's it for colonial morphology. So I'll see you on our next lecture on our bacteriology class. Okay, so keep safe, dear. See you soon.